So this is example number 2, and again, pause the video, enter the data. The following data are water levels recorded on November 18th and 19th, 2005 at Oak Bay Station in British Columbia. Time is in hours and depth is in meters. So once you have your data entered, you're going to do a sign regression, and we'll set the appropriate windows and we'll sketch the graph that's produced. So again, stat, over to calculate, arrow up to the sign regression, enter, 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 enter. Put in your Y1 here, vars, over to function. I already have it in, so I'm not going to do that. Store it, get the equation to store it, and then calculate. And so we've got our equation. I'm going to write my equation down. I have y is equal to 1.101 times the sine of b, which is 0.213x minus 1.394 plus 1.843. We're going to sketch the graph. Well, let's take a look at our graph. And you can see how this data isn't as smooth and perfect, and part of that is because it's actual measured data. And there's some fluctuation at the time of the reading and those kinds of things. It's not as straightforward as it always appears. So let's look at our windows. We have our windows. X is 0 to 30, and I'm going up in a scale of 1, increments of 1. For the Y, I have 0 to 4, and I have increments of 0.5. So when we go to our graph, I'm 0.5, I'm between 0.5 and 1. So this is 0.5, this is 1, and I'm starting, and my maximum is about 2.9. So this is 1, 2, 3, and so again it's going about like so, up and coming down like that. So now we're going to use the graph or the equation to estimate the max, min, median, amplitude, and period. Well, we can do this in a variety of ways. As they say, use the equation. If we use our equation, we can take to get the max, we take our amplitude A plus our median. So we have 1.101 plus 1.843. We add that together. And I forgot my decimal. Let's just clear this. 1.101 plus 1.843, and so we get a maximum of 2.944. To find our minimum, again from the equation, we take D and we subtract A. So we have 1.841 minus 1.101, and that gives us 0.742 as our minimum value. And remember, these are meters, these are our heights of the water. Our median comes right off the graph, that are right out of the equation. So the median line is y is equal to 1.843, and we know that our amplitude is 1.101, and again these are in meters, and our period. Remember, we can calculate the period by taking 2 pi and dividing it by b. So 2 times pi divided by b, which is 0.213. That's, notice I have 0.1 extra, a decimal place in front there, so let's just fix that. So it should be 0.2, and that gives us 29.5, and that would be in hours. Okay, so that is from using our equation to calculate this. Now, if we were just working with the graph, what I would do is, from the graph, I would have the equation, have the calculator find my maximum and my minimum. So let's do that. Let's go second and trace. We want the minimum, which is the third item on the menu. I can only calculate the minimum way over here. So this is my right, or my right, yes, the left bound. Now I'm going to go move across and get my right bound. I have to go past the minimum, so it's just, I can just go past it a little bit, press enter and have a guess, press enter for the guess, and I get 28.6. And this, remember, this 2.13 is an approximated value. We rounded it, and from the graph we get minimum. Our x value at that minimum is 8. Let me just grab this here. So the period is 28.63 hours. So a little bit different from what we're getting from our equation. Again, in part because that 0.213 is an approximated value. And our minimum value here is 0.742, and that's in meters, and that comes right off of the y value for our minimum. If we do our maximum, so we go second, trace, and number 4 for maximum, we have to move our cursor over to the left side of the maximum. We press enter, go over to the right side of the maximum, enter again, and have it calculate our maximum value. So we get a maximum value of 2.944, which is identical to what we got from the equation. Now, this allows us to calculate our amplitude because we can take the maximum and subtract the minimum, divide it by 2, and that gives us our amplitude. So 2.944 minus 0.724, or 42, let's go and calculate that. 2.944 subtract 0.742, get that division, divide it by 2, and oops, divided by 1. Let's divide it by 2 this time. And we get an amplitude of 1.101, which is exactly what we got from the equation. So our equation represents that. Now we can find our median line. by taking our max. This time we add the minimum and then divide it by 2. So again, 2.944 plus 0.742, and then we divide this by 2, and that gives us again the median that we received, that we took right off of the equation. Okay, so that's question B. Let's move on to question number C. Use your graph to estimate the depth of the water at 9:30 p.m. on November 19th. Is the tide coming in or going out at this time? So let's go over to our calculator. We are going to use second and trace again, the calculate menu, and we're going to calculate for a specific time. We've been asked for 6:30 on November 18th. So and that's in the PM. So let's just scroll up in our data and remember, again, we're not scrolling up. There it goes. It's just taking a minute. So this time would be at midnight, the morning of the 18th, and then for 6 o'clock, remember that this is noon, and 6 o'clock is here. So this is 6 p.m. is 18. And we're looking for 6:30, so that's going to be 18.5 as our x value that we're going to use. So we'll calculate it. X is equal to 18.5, and what is y? So our y value is 2.455 or 2.46 meters. And notice you can see flashing here is where our cursor is, and the water level is going down, which means the tide is going out. So let's go and answer this question. So the depth is 2.46 meters, and the tide is going out. Now, let's look at question D. Between what times is the depths of the water more than 2.5? So somewhere here we have 2.5, and we're looking at finding those two values and the time in between there when it's over 2.5. Okay, so we go into y equals. In y2 we enter 2.5, and then we are going to look for the intersection point, so that's number 5. And I'm going to take second and trace. Oh, sorry, number 5 again. Let's do that. And now it's asking us first curve, second curve, and yes, yes. So enter, enter. Now it wants a guess. I'm going to move my cursor over to this second value here. Okay, and press enter. And so it's at 18.27. So our time is, for the second time, is 18.27 hours. Let's find our first time. So we do the same thing again, second trace, intersection point, which is 5. I'm going to move my cursor over to the intersection point on the left. I can press enter to say yes for the curves, take a guess, and it calculates, and it's at 9.53. So 9.53 hours. Now, let's turn these into times, right? We don't think of 0.53 of an hour, so let's convert that into a time. So second and mode to get out of here, we're going to take 0.53, multiply it by 60, that gives us the number of minutes, and so this is 932, and this is in the AM. And now we've got 1800 hours, or 1827, or 18.27. So remember, we used the 18 for 6:30, so this is 6 p.m. and the 0.27 is a part of an hour. So let's take 0.27, multiply by 60, and that tells us how many minutes. So it's 16 minutes. So this is from 9:32 a.m. to 6:16 p.m. So the water is more than 2.5 meters between 9:32 a.m. to 6:16 p.m. And that's our last example. Here are some practice questions. If you need to get a hold of me, send me a message in Moodle, or even better, use my email, and you can email me directly, karen.perry@portagecollege, all one word, all lowercase, no spaces, .ca, and I'll be happy to answer any of your questions. Have a good night, and I will talk to you on Monday. Bye for now.